I'm going to be talking about the history of climate change. Let's start with the big picture. Earth's climate has changed many times over billions of years. Long before humans started burning fossil fuels, a major driver of these changes is Earth's orbit, through what is called the Milankovitch cycle. There are three key cycles. First, Earth obliquity, which tilts every 40,000 years, changing how much sunlight reaches different parts of the Earth. Then there's the eccentricity, which changes Earth's orbit. Earth's orbit shape every 100,000 years, bringing Earth closer or farther from the sun. Together, these orbital changes affect Earth's long-term climate patterns, like triggering ice ages. To study past climate changes, scientists use ice cores, sediment layers, and tree rings. These records show how temperatures and carbon dioxide levels have varied over hundreds of thousands of years. But today, changes are happening much faster than anything ever seen before.
Effects of climate change. The most noticeable effect today is rising global temperatures. This leads to habitat and species loss, more frequent and intense droughts, soil drying, extreme heat waves, and interestingly, increased precipitation in some regions. Sea levels are rising too. That's happening because of two main reasons: melting glaciers and polar ice, and thermal expansion, which is when warmer water takes up more space. Another big issue is the melting of permafrost, frozen soils in tundra regions. As they thaw, they release methane and carbon dioxide from anaerobic decomposition. Since methane is an extremely potent greenhouse gas, this could speed up the global warming even more.
Coastal communities are especially vulnerable. Rising sea levels lead to more frequent flooding, shoreline erosion, and saltwater contamination of freshwater. We're also seeing major property loss and damage. Poor communities that can't afford massive infrastructure upgrades may even need to relocate inland. Entire towns could be open dry protecting areas are being lost to the without them, coastal communities and human settlements become much more expensive.
Next, I'll be talking about climate change effects on atmospheric currents and the jet stream. Climate change is also shifting how air moves across the planet. The Hadley cell, a major atmospheric circulation system, is widening and weakening. Warmer air at the equator now travels farther before sinking, expanding dry zones farther from the equator. Meanwhile, the jet stream is weakening and stabilizing. The Arctic is warming faster than lower latitudes. Normally, a strong temperature difference between the equator and the poles drives a strong jet stream. Now, with less difference, the jet stream becomes wavier and slower, causing extreme weather like prolonged heat waves, cold spells, and flooding.
On land, rising temperatures are causing species to shift their ranges for the poles. Some of them are almost like that. Others fish are also moving to cold water. Sharks fishing going moving to widespread coral bleaching. Meanwhile, oceans but CO2 so good provide the entire marine food web.
Impact on ocean circulation. Another major concern is the impact on ocean circulation. Also known as the global conveyor belt, this system moves heat, salt, and nutrients around the oceans, regulating global climate. However, with more fresh water entering the oceans from melting ice, the circulation could slow down or even stop. Fresh water is lighter than salty water, so it disrupts the sinking motion needed to keep the system going. A suppression of thermohaline circulation would dramatically change global weather patterns, harm ocean ecosystems, and could even cause regional cooling in places like Europe.
And lastly, we'll be talking about climate change's impact on the polar ecosystem. Finally, polar regions are heating up at alarming rates. Polar amplification means that the Arctic is warming about 4 times faster than the global average. Melting ice exposes darker surfaces that absorb more heat, creating a dangerous feedback loop. Meanwhile, permafrost, permanently frozen soil, is thawing, releasing methane and carbon dioxide. These greenhouse gases further speed up climate change. The loss of ice habitats is devastating. The loss of ice habitats is devastating species like polar bears, walruses. The loss of ice habitats is devastating species like polar bears and walruses. While melting Antarctica, glaciers are adding to global sea level rise, affecting ecosystems worldwide.